Hi, welcome to day 4 of Advent of Code. Let's read the task. Okay, the gondola takes you up. Blah 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 blah. Yeah, let's read it actually. So, I got all these scratch cards as a gift, but I can't figure out what I won. The elf leads you over to the pile of colorful cards. There you discover dozens of scratch cards, all with their opaque covering already scratched off. Picking one up, it looks like each card has two lists of numbers separated by a vertical bar, a list of winning numbers, and then a list of numbers you have. You organize the information into a table, your puzzle input. As far as the elf has been able to figure out, you have to figure out which of the numbers you have appear on the list of winning numbers. The first match makes the card worth 1 point, and each match after the first doubles the point value of that card. For example, card 1 has 5 winning numbers here, then you have a bar, and you have 8 numbers that you have. Of the numbers you have, 4 of them, 38, here is the winning number, 83 is a winning number, and so on and so on. Yeah, there are 4 winning numbers. 4 of the cards have winning numbers, and card 2 has 2 winning points. It is worth 2 points. Card 3 has 2 winning points, so it was 2 points. The card 4 is worth 1 point. Cards 5 and 6 are worth no points. And the sum gives us 8 plus 2 plus 2 plus 1. The answer is 13. Okay, now we just have to handle the pile of cards. Okay. Let's create the example. Interesting. What else? Stack in it. What do we have here? Stack YAML, Cabal, init. Yeah, I'd like an executable. Do you wish to overwrite existing? No. Oh, yeah. Cabal. Why are you so Cabal? Set notations. I don't want to spend time on that. Nah, whatever. I want an elf license. Are you kidding me? 1. Okay. Project category. Don't care. I don't care. Add informative comments. No. Wow. Project contains no local packages. Again, some Cabal bullshit. Yeah. Build depends. Oh, they have different ideas. Stack YAML. Okay, and what if I remove stack files and do stack init now? Stack run. Oh, okay, that's how we do it. First you initialize a Cabal project and then you initialize a stack project. Good. So, app main HS. So, what do I want to do? I want to read the file, and then for each line I want to do something. Okay. Yeah. Let's start with the usual. Oh, it's not actually head, it's fpath. So pass in the name of the file. Can I just write it in full at args? Find, is this correct? Variable not in scope. Yeah. Okay. Import qualified. System environment is env. Okay. Environment get args. Defined but not used. It makes sense. Now should I try to use a state monad directly? No, I think I can get away with laziness. See what I did here? And actually, let's just solve it. Solve 1. So it takes a list of lines and it produces an int. And for now, it's undefined. And in the end, what we do is print in the solved value. So let's read the input and let's split into lines what we read from fpath. Okay, and then I pass input to solve 1 and eventually it will solve the problem. Could not match expected type string. Oh, yeah. That must be a list, not a tuple. Yeah. Okay. Stack.gci. Defined but not used is just a warning. Okay. Now let's think about solving the task. So iterate over lines, accumulate winning points into a can this be a multi-set? So I had this idea of just using a set to avoid to test if the numbers in the right part are present in the left part. But can it happen that winning points are not unique? Question: can there be duplicate points. Third one, so the third one, after that, iterate over lines. Okay, and test the right side numbers for presence in the search structure. The second step is to take the list of winnings and sum it up. So that is starting to shape. So we will have the list of winnings and we will sum it. So map input. Scratch card points, and scratch card points is taken a string and returns an integer that describes scratch card SC. And okay, now let's reload. Defined but not used, that's fine. Scratch card points card 1. Let's just copy paste it, and it should give the winning. It should give the score for this scratch card. Okay. In order to do that, what do I need? First of all, the 0th of all, I have this anticipation need this structure in the future. So what I do now, I don't just accumulate. I don't want to just accumulate the result. I want to actually produce a useful combinator that might be useful later. I want to be able to parse a scratch card. Parse card. I want to be able to parse it into what? I think this, for now, it will be a tuple of some structure that allows a fast search over it and a list of numbers. And this mysterious structure will be search index. Let's just call it winning numbers, win nums, whatever. And win nums. Okay. And this mysterious structure will be what exactly? Do I have binary search over arrays of numbers? So package array mutable and immutable arrays. Binary, no. Mutable array, I believe. Let's take a look. So I believe these are some top level interface definitions. search. Do we have any search? Accessing arrays, incremental array updates. No. And array IO? No, I don't want array IO. What's this? Array, array constructor, list array, accumulate array, accessing arrays, bounds, indices, elements, incremental array updates. Interesting. That's not what I want to see. Oh, could it be in the array base? So a class that describes an array is consists of bounds, number of elements, unsafe array, and unsafe add. Makes sense. Safe index, unsafe replace. The constructor array, the list array in the monad st. Okay. Then what? Indices, elements, accumulation, a map, an index map. I wish I was writing this in Rust. I would have binary search as a built-in method of any slice. And now it's just... there is no search. Okay. Maybe vector has it. It's a slightly higher level, and it brings more with it, but maybe it also has searching. Wow. Find index R. Does not fuse. Find. This looks like a linear search. This is the search for an index by a predicate. Haskell vector binary search. Vector algorithms. Okay. Okay, I think I'm fine with it, yeah. So, X for Cabal. Build depends on vector as well, and vector algorithms. Stack build. It will build at some point. Binary search. Search by L bounds. And if I have more than one number, I could actually need to remove the numbers. Okay. I don't care. Let's just throw in containers and do that with maps, because yeah, I just want a generic data structure that is fast enough, and not this kind of things. Okay, parse code. So the generic structure will be I cannot type. Yeah, that was the right I. Qualified Data.Map as M, and let's say that this is a map from the number itself into its count. How many times we have seen this in numbers? Okay, and now process cards. We have a scratch card, and first of all, let's just drop everything until the semicolon, the colon, not semicolon. Take while. Oh, it's not actually take while. I think it's something like split split at. Oh, wow, Haskell. Haskell is taking forever to compile vector libraries. Batteries are obviously not included. Okay, while it's doing its thing, let's just... Oh, okay, it cannot build what I just wrote. Yeah, that makes sense. Yeah, it works more or less. And now let's do import qualified. What do I want to see? Oh, a data list. It's L. And I want to see if I can split at split by, I would say. Maybe I should also do another good thing, and I should use text right from the start, because the native strings are very inefficient, I would say. So let's just look around. Did it include... Okay, it looks like the text is here already. Oh, maybe it was masked, that's why Cabal or Stack did not need to build it. Okay, let's try to bring it in. Import qualified data text as D. So now, and now I have to fight many small questions. How do I create a text string, actually? And this is from... I remember it was something very unobvious, like pack. So you get a list of characters and you pack it to create a text string. Yeah, Haskell, why? Okay, and I also need import qualified data text IO st also. And here, do I have read file? I do. So, should I just replace string with text everywhere? Is it a good idea? No, no, I don't need that because I don't need to store it right now. Okay, so let's just implement it using string. All I need is just iterating over characters. I don't need to store strings efficiently, and I don't, and at this point I don't need to index strings efficiently. So Scratchcard points. So let's just parse the card. So my question was, how do I ignore everything until the first colon? So let's assume I have and I want to get... Oh, again, Haskell is very unhelpful. Scan all singleton sort by unconstant pose take while. Oh, actually, take while is not equal to colon. Where was my string? Yeah, let's just call that a string. Let's just take while is not equal to a colon, not a semicolon, colon. And then, oh, actually I need drop while. Drop while. And then I can drop one. Oh, actually it is called tail for lists. Maybe I can be explicit and just say that it's okay. Okay, so okay, let's keep it undefined for now. Numbers, SC. Let's say that this is equal to drop 1, drop while is not equal to this one, and I parse the given scratch card. Okay, now is there anything like split by white space? Yeah, I remember, it is called words. And if I do words here, that's very close to what I want. Yeah. So the thing is, I have to accumulate So, and then I can just say that wins are words SC1. What was called this predicate which just partitions, not, is it break or partition, which takes a list, applies a predicate and takes everything while this predicate holds. But it was another thing, something like partition, I believe, that just that goes through all of the list and just unzips it by a predicate, I believe. And it has the same, exactly the same type. And you cannot say by type which one is what I want. Okay, is that a thing? Yes, that's good, that's good. Yeah, perfect. So, break, apply to a predicate and a list returns a tuple where the first element is the longest prefix, possibly empty, of that do not satisfy. Yeah, that sounds like what I want. So, break on a bar. Yes, and let's call that ends. And let's break on a bar, ends, not BS, ends. Okay. Oh yeah, right. I have to invert the index. So, and now, yeah, I have it split into two lists. That wins strings. I have the winning numbers and I have the just regular numbers. They are lazy, so they are not stored anywhere. It's just a thunk at this point. It's just the continuation that has not been read yet, so it's okay. Wins, I think it's a computed thunk at this point, so let's... yeah, now I have all the parts that I need, right? Let's say that numbers are map read nums, and this will be the numbers, and the winning structure will be wins will be mapped from wait group. Is there a way to actually group numbers and get the count in each group? This kind of aggregation. Why do I care about this right now? Should I care about this? I really don't know. So, from list. So let's assume I have the list of 1, 1, 2, 3, 5, 6. How can I count each number? If I group it, yeah, it has to be list group. Yeah, and if I map it with, so I get a slice which I can call A. It often clashes with let's call it G group. It is not pretty, but at least it makes sense. And I want it to map into head of the group and the length of the group. And yeah, now I know that I saw 1 twice, I saw 2 once, I saw 3 once, 5 once, and 6 once. Okay, yeah, good. And this is the input to map from list. Basically, take a group, I take a head of the group, take a length of the group, and I group the sorted. I need to sort it, and I need to sort it by I need to sort the winning numbers, winning strings. Why is it redundant? Oh yeah, the dollar is redundant. Yeah, redundant brackets. No, I like my parentheses here. Haskell, you're not right. I'm right. Okay. Okay. Here, winning wins. Redundant brackets found. Variable not a scope. String. Sort. List sort. Interesting. Oh, I don't have the list in the scope. Okay, let's go back. Load. Now what? Expected win nums actual m. Haven't I parsed? I also have to parse wins, right? Okay. Map read wins. These are just warnings. That's good. Okay. Yeah, let's just test it out. So I say again that s is equal to the actual s, this one, and then I say that an s is equal to this, and I destruct it into wins. Oh, actually I could just call passcard on s. And what do I have here? I have a map from the winning number to the count of this winning number, and I have the rest, which is just a lazy stream. But it was printed out, so it had to be evaluated. Okay, now what? Let's assume where I have winnings and numbers, and this comes from the parse card C. Okay. And then I process that. I map numbers with something that I need to figure out. Oh, yeah, it is really just a filter. So I filter the nums by I have a number and I have to check if it's in the list of the winning numbers. Right now, do I even care about... Oh, not state again, please. Yes, in the future, if I have multiple winning numbers of the same, multiple equal winning numbers, and I have multiple present numbers, I have to deduct the amount of sin numbers from the winning numbers that I have to know that, for example, I have two winning numbers 12, and I thought three numbers 12 in the numbers. So I have to be able to say that only the first 12, only the first two 12s are winning. But yeah, should I really care about this now? So what I filter by? I filter by the presence of this number in the winning index, as if search index. So what do I do? M lookup numbers, no, wins, lookup what? N in wins. And does map has anything like contains? Oh, in Haskell it's usually called lm or member. Yeah, member. Why? Please be uniform. It's just... So in lists you check with you check that an element belongs to a list via this function, but for maps you check it via member, and no language on earth uses member for this. This could be called contains. Please be consistent. Okay, so now I know that to test if a map has this number, I can just do this. And now I can sum them. and I can, and I need to the power of 2, right? 1. How do you do power in Haskell? Okay. Okay. 8. Oh, it's actually the number of it's 2 to the power of the number of winning cards minus 1. So yeah, if you have 1 winning card, you have 1 point, right? And if you have 2 winning cards, not 12, then you have 2. And if you have 3 winning cards, you have 4 points, right? That's not the right place. It has 4 winning numbers. That's why it is worth 8 points. Okay, and as I know already, I have to I have to okay, let's write it in a civilized way, not this Haskell weirdness. X minus 1, 2 to the power of x minus 1, and oh, it's a floating one. So how do you do the integral power to, oh, okay, yeah, I see. Oh, does it work now? It seems to. So let's bring back our s. Let's try Scratchcard points s. 0. Oh, nice. Okay, something is wrong. Why? Oh, this must be length. Yeah. You're right. Yeah, it's 8. What if I remove 48? I don't care. Yeah, it's 4 now. 48. It's 16 now. Actually, I don't know. Maybe I don't have to check for the number of... maybe it's really the case that if you have 148 here, then for each 48 here you double the points. But okay, yeah. And now let's just verify that it works for the example. Step 1, example. Negative exponent. And this is because... I see. If x is equal to 0, then 0, else this 10 is then equal to 0. Is it written this way in Haskell? No. Yeah, it works this way. Okay, so let's run step 1 again. And it produces 13. Okay, so where is my input? Yep, input. By the way, save it for input.txt. Yeah, input.txt. Okay, it gives this number, but one more fun is I like to print out any cases where I have two winning numbers, if there are such cases. So, it was that thing, debug trace. Do I have sequence? Yeah, I have seq. But I really need trace, right? Trace show, right? Yeah, it takes anything that can be shown, displayed, and then it just traces it. Okay, so import debug trace show, and then I say that I want trace show. And what do I want to trace? I want to trace filtered by the keys. So how do I filter maps? But I really want I want just to filter it and see what happens later. So I filter the map by the predicate that its value is more than 1, and the rest should be shown. What's wrong with you? I think it's better to do it like this. So what is the type of M filter? Oh, it produces a map, but it's, oh, it takes filter first, right? Yeah. Okay. Oh, it cannot be parsed. Why? Because this needs to go to parentheses, and yeah. Now main input txt. Okay, we don't have any multiple winning numbers. Another question is, okay, yeah, it doesn't matter much. So stack run on input txt. Let's just take this number. Wait. It's okay. Let's just try it. Okay, that's the right answer. Yay. Let's comment out this part for now. And now what? Now the second part. Add changelog, license, stack, cabal, input, example, add main. It's state. That sounds good. It commits Advent of Code 2023, day 4, Scratchcards in Haskell, part 1. Yay. Now let's take a look at the part 2. Just as you're about to report your findings to the elf, one will realize the tools have actually been printed on the back of every card this whole time. There is no such thing as points. Instead, scratch cards only cause you win more scratch cards equal to the number of the winning points you have. Okay, specifically, you win copies of the scratch cards below the winning card. Equal to the number of the matches. So if card 10 were to have 5 matching numbers, you would win one copy of each of cards 11, 12, 13, 14, and 15. What does it even mean? So if you win a copy of card 10 and it has 5 matching numbers, it would then win a copy of the same cards that the original. Well, cards will never make a copy of cards past the end of the table. Okay, this time the above example goes differently. Card 1 has 4 matching numbers, so you win 4 next cards. Okay, makes sense. Your original card 2 has 2 matching numbers, so you win one copy of 3 and 4. Of each of 3 and 4. Your copy of card 2 also, okay? Your 4 instances of card 3 have 4 instances of card 3 have 3 matching numbers, so you win 4 copies. What? Your 14 instances of card 5 have no matching numbers and win no more card. Your 1 instance of card 6 has no matching numbers and wins no more cards. For instances of card 3. Okay, yeah, let's think about this. So I'm back. Yep. Let's understand this example quickly, and let's say card 1 has 4 matching numbers, so we win one copy of each of the next 4 cards. 1, 2, 3, 4, 5. So at the start you had cards 1, 2, 3, 4, 5. Then card 1 wins you a copy of 2, 3, 4, and 5. The original card 2 has 2 matching numbers, so you win one copy each of 2 next cards. So for each 2, you win a copy of 3 and 3, and a copy of 4 and 4. Your 4 instances of card 3 have 2 matching numbers, so you win 4 copies of the number of each of the cards 4 and 5. So this is something like this. And your 8 instances of card 4 have 1 matching number, so we win 8 copies of card 5. And now I am a bit lazy to do that manually. 5, and I just put it here. And that gives us 14 instances of 5, but they do not produce any new cards. And 6 also does not produce any new cards. So the task has to be modified. What we sum up is not the winnings of each card anymore. Now Now. We have to post-process it also. And so solve 2. It also takes a list of lines and produces a number. It's undefined for now, and it's input. Okay, and I need to solve. Use it. Okay. Now, what else? I have the map. Scratchcard points input. First of all, undefined. I can prepare a map of how much each ID of the card wins you. So let's have wins, which are map scratchcard points input, and actually this will be zip width because I want to know the index of the card. I want to index them, and here it's actually an index and a scratch card, and I give back the index of scratch cards as C, and I get the list of wins scratch card points. This is an int. Well, I could just index it there. The order is still the same, so I could just map it with scratch card points, and then I could index it here, and then I could create a map from this list. Okay, now I can map a card ID into its winning points. Good. Okay, what am I talking into? Oh no. Okay, doesn't matter. And then when I have the wins, I have to iterate knowing the indexes and knowing the amount of cards. So basically so iteration will go like this. I have to fold from left to right. I have to fold indexes from 1 to as long as it takes, and this means m lengths. We have m lengths. Oh, was it m size as usual in Haskell? Oh, I get it why they have different names, because if you do an unqualified input, size for a map will clash with length for the list if it would be called length. Okay. M size, what? M size, not wins. Okay, I use wins in a different sense here. Here I map from a map from card number to the points it wins. Okay, and here, what I can do? Does mfoldle iterate in the order of elements? Okay, that's an interesting question. Let's assume so. Okay, so let's fold the wins with, so the initial state is, what the state is, I have a map which tells us how many cards we have. Additional cards we have. Yeah, additional cards. So this basically maps from the card ID to the number of additional cards. And by default we have one card because we have all of the IDs. Okay, and we fold with some routine go. Okay, what does it look like? Let's read the definition of the type of the map folder, and it takes a callback. Do I need the key here? I think I do. Does it iterate in the order of from less to more? The order of keys. Yeah, it does iterate in the ascending order. Yep, of keys. Okay, good. So what do I want to have? So let's assume that I have a folder, and let's assume I want to from an empty string, and I want to state string m. I want to append this number 11111. Oh, because it iterates over yeah, it iterates over values. Yeah, what do I want? With key go, and now go becomes folder with key. Now it takes a state, takes a key, and takes a value. So when I map over bins, the key, the state is map. The key is card number, and the value is card points. So and also we have to collect the number why do I have this crap? Can I just do it recursively without fault? Yeah, why not? I have wins. I also take the map of additional map. Also, I have the wins in the scope. Okay, that's good. So I have a map that tells me how I map card IDs, how many additional card IDs I have. So it maps a card ID into the number of additional cards. Yeah, and at each step I iterate over indexes, right? So I have to have the current index, and if index is greater or equal to m size wins, then it also have to accumulate some result, which will be in that case it is the result, otherwise no map. I have the index, I have the result, and it all starts with first an empty map of additional cards. It starts with the index 1 and it starts with the result of 0. Wins are used in the scope. Okay. So now I have to compute. Let's something in Go nummap 1 I plus 1 and r plus total winnings at this time. So now I have to compute nummap 1, which is undefined for now. I have to compute points, undefined, plus points. Okay. Nummap 1. So how do I calculate nummap 1? I know the index of the card that I have. So I know the number of cards at this point, and it's equal to 1 plus maybe 0 from maybe 0 and lookup of so what do you look up? The index of the card in the wins map, in the num map. Okay, yeah. So now I have the number of cards at this step. For example, for the card 1, I should have 0 additional cards, so I have one card in total. For card 2 in the example, I have 1 original card and 1 additional card, and so on and so on. So that number determines the points. So in order to get the points, I have to get from maybe 0 of, actually this better looks like this. I look up the points in the wins map for the current card. Yeah, that sounds good. Yeah, from maybe from maybe, not from just blows up if it is nothing. Okay, okay, yeah, I think it's a good advice finally to move brackets here and not use dollar internally. Okay, so I calculated the points that I need to add to the result, and I just need to change the map. I just need to change the number of some cards depending on how many points were won at this point. So looking at the second step, let's go back to the file. For example, at this step, let's roll it back again. For example, yeah, let's look at step 1. We are at step 1, I is equal to 1. And we have won 4 points. Oh, I don't need to compute the points. I need the number of matching cards. Okay. Yeah. So, in order to do that, where is the solve 1? Scratchcard points. So I need to compute the points. So actually card not points, but the number of matching cards, matches, matches, and and all this goes into the previous to the place of the previous call. Yeah. Let n is equal to Scratchcard. Let n is equal to card matches for Scratchcard in if n is less or equal to 0 than 0, else n to the power the 2 to the power of n. Yeah, that gives the number of points. Okay, yeah, that still sounds good. Okay, so in wins, I actually computed the number of matches for each card. Matches. Win map, I would say. Win map. And actually, it has to be strictly larger than the size of the win map. Okay, and these are not points exactly. So the card 1 wins you how much? Your one instance wins normal cards. Okay. Has 4 matching cards. So you win 1 copy of. Okay. Regional has 2 matching numbers, so you win 1 copy each. Okay. So what do I need to compute? You ultimately have to. Oh, you have 30 scratch cards. So all I have to do is just. I just have to sum the number of the scratch cards, right? The total number of one scratch cards. Okay. And then I have to update the cards that I won at this point. So for the range of from index to how do you say exclusive in Haskell? 1 to 0, 1 to 1, 1 to 2. Range, does it have range? Unknown. From yeah, it always uses inclusive ranges. Okay, so to be inclusive, what do we need? Points minus 1. Okay, and these are the cards that should be each multiplied by the current n and added into the pile of the remaining cards. Okay. Actually, I don't even need the result right here. I just need the size of the remaining map. Right? Map. And I just need the size of the remaining map. Perfect. So what do we do now? Map. Why does it not complain? Because yeah, now it is able to complain. Okay, that's good. Okay, so line 26. Let's bring it to the center. Could it match the type? Go empty. Starting from 1. I don't need the result anymore. The result of this function is the resulting map. And it's not a size, it's do you have the iterator over lambs? That should give you the list of values, right? Yeah. Lens, and you have to use sum. Could not match the type. Why? With actual type. Okay, let's read again. So 26. What's wrong with it? Map empty. Map plus these are additionally one cards. Okay. So okay. So for each of these things, I have to foldle. Come on, not foldle again. Oh, come on. But here it really is foldle. And I take the map as the starting point. And what do? I get the index. And I get the map first and the index second. What do? I say that for the card, what was the method for updating the values? Map alter with something by key I map m. Yeah. And here, what do? Case if so maybe I get the existing value of the key, and from maybe 0, and here I handle the existing value of the key, and that means that I have to increase it, and that gives the total number of cards. And then I have to say that this will be just of adding n existing cards. View. Okay. So yeah, that should solve it ideally, but the module is loaded. Okay, I just want to trace that I really understand it well. So trace show. What do I want to show? I want to show the num map and the index and the num map at each stage. Reload and main input example txt. 50. Why the hell do I get 50? So on the first iteration, oh, these are additional cards. Okay, yeah. I can actually remove that. Okay, yeah, okay, yeah, makes sense. Example 28. Why? So on the first step, I had 0 additional cards. On the second step, I have 1 additional card for 1, not for 1. No, that's my mistake. where I do it arrange here, and I do it here. Okay, yeah. 30. Yes. Let's just check quickly that it makes sense. So the first step, we had 0 additional cards for every card number. At the second step, we had 1 additional card for 2, 1 additional card for 3, 1 additional card for 4, 1 additional card for 5. At the third step, we had 3 additional cards for 3. That's correct. And 3 additional cards for 4. Yes, and still 1 additional card for 5. Yeah. So on the list, on the step 4, we had 1 additional card for 2, but that doesn't matter at this point. 3 additional cards for 3, and 7 additional cards for 4. Does it check out? Yeah. And 13 additional cards for 5. And 14 cards for 5 in total, right? 1 original and 13 copies. Yeah. And then 13 5 cards produce 0 new 1 cards, and here it's just 0 new 1 cards. Okay, yeah, that sounds right. Hopefully, yeah. I don't know if it works for the big input. So step 1, example txt, it should produce 30, and the input txt. Let's hope that this is correct. Yes, it is. Yeah. That's the point where I like Haskell.